What you need for this is tinfoil, Christmas lights, tape, some batteries, 9 volts, some AA or AAA, paper, and wire cutters. You want to cut the bulbs off and then strip the wires so that you can actually see the wires. And then you want to tape it, tape the tinfoil to paper and then tape the wires to the tinfoil to create a circuit. And you can create a parallel circuit like we have here, and we're using 2 AAA batteries, but you could use 1 AAA, 1 AA, 2 AA, whatever you have on hand. Or you can create a series circuit like we have here, and we're using the 9-volt battery with this. And then we wanted to see if we could make the lights brighter, so we took one of the lights out of the circuit and then reconnected the circuit to see if we could make the lights brighter. And we did! What you'll need is candy canes, of course, some cups, vinegar, baby oil, and hot and cold water. And then you just fill up the cups. That one had cold water in it, and then that one I put baby oil and vinegar, and then hot water in that one. And then you just stick the candy canes in and see which ones dissolve faster. You can make predictions and guesses. And then we'd watch the experiment, which one was dissolving the fastest, which one wasn't dissolving them at all, and of course, he took a few bites. What you need is either a hot plate, or we used our coffee maker, or you could even just do it on your stove if you're comfortable with that. We used a tablespoon of benzoic acid, a glue gun, some little figurines, a mason jar with a lid, and safety goggles because we are using benzoic acid. And then you glue your little figurines to the top of the lid, or the underside of the lid, I should say. Then we heated our benzoic acid and water on our coffee maker for about 15 minutes. You don't want it to boil. And then as it cooled, you can see it created these beautiful snowflakes. Like I said, we used a tablespoon. I think that was too much. If you notice that our little astronaut, he has a lot of snow in his little jar. Maybe half a tablespoon would work a little better for this. Benzoic acid doesn't dissolve in room temperature water, but when you heat the water, the solubility of the molecule is increased, kind of like dissolving sugar in water. Cooling the solution causes the benzoic acid to go back into solid form. Slow cooling of the solution allows the benzoic acid to form prettier, more snow-like flakes than if you just mix the benzoic acid with water. This is a fun one. What you'll need is dry yeast, 3 tablespoons of warm water, an empty bottle. You could use a 2-liter bottle, 12% hydrogen peroxide. You could also use 6% or 3%. Dish soap and food coloring. You'll also probably want an empty pan or something to catch the foam in. And because we're using 12% hydrogen peroxide, safety goggles. First, you'll want to mix your yeast and your warm water and stir it up a little bit, and that's going to be your catalyst for this experiment. Then you'll want to add half a cup of the hydrogen peroxide into your bottle, and then you put some dish soap in it. There's no specific amount for the dish soap. And then if you want the stripes on your toothpaste, put your food coloring on the sides of the bottle. And then you add your catalyst. And this creates an exothermic reaction. So you can actually feel how warm it gets. And it is safe to touch. and it's a lot of fun to play in. So if you haven't tried this one, I think that you'll love it. What you'll need for this is tin foil, candy canes of course, and a pan. First we talked about if we could bend them. Is it hard? And we found out we couldn't. Then we bent the tin foil in different kind of patterns and guessed what would happen when we put it in the oven. And then we baked it at 350 for about 3 minutes. And once it cooled for about a minute, it was safe to touch. And this is when you can kind of bend them and twist them. And we talked about how heat changes the properties of the candy canes. And as they cooled, they went back to being hard and we couldn't bend them anymore. What you need for this is ammonia, bluing, salt, a measuring spoon, a dish, and then another dish to mix in. And you'll want thin cardboard like the back of a notebook. So I already have 3 tablespoons of water in there, and then I added 3 tablespoons of bluing, 3 tablespoons of salt, and 1.5 tablespoons of ammonia, and then I mixed it up. Then you want to cut your tree shape out of the cardboard and cut a slit in the bottom of one and the top of the other so you can make a 3D tree. And then I added food coloring to the ends of my tree. I use green, but you could use blue or red or any kind of colors that you want to use. And then I put my mixture on the plate and added my tree, and then just watched it grow crystals. This works because of capillary action, evaporation, crystallization, and saturation. Pretty cool, huh? You might have done this one before, it's pretty easy. What you need is borax, hot water, a string, a pencil, and some pipe cleaner. And then you just make your snowflake or whatever shape you like, add the string, tie the string to the pencil, and make sure that the string isn't long enough so that it doesn't touch the sides or the bottom of the cup. And then you want to add 3 tablespoons to 1 cup of borax, 3 tablespoons of borax to 1 cup of water, I should say, and then put it in there and wait overnight. And the next day you'll have a crystal ornament. What you need for this is a jar, vase, cup, something like that, candle, baking soda, and vinegar. And then you just put some baking soda in your jar and add some vinegar, and then you just pick it up and pour the air on the candle, and it goes out like magic. All you need for this is a piece of PVC pipe and some Christmas tinsel. Take 3 to 6 strands of tinsel and tie them together on each end, about 6 inches apart. And then you cut off the excess on the end. And when you rub the pipe in your hair or give it a static charge, you're giving it a negative static charge. The orb is at first attracted to the pipe because it has a positive charge, but as soon as the orb touches the pipe, it picks up a negative charge. And since the pipe is negative and the tinsel orb is now negative, they repel away from each other and it makes the orb levitate. What you need for this is some oranges, and we're using a bucket of water, but you could also easily use a sink. You'll notice that the unpeeled orange floats. That's because the rind is very porous and filled with tiny pockets of air. Even though you're removing mass when you peel the peeled orange is more dense and sinks in the water. So what you'll need for this is a bowl of water, some clear nail polish, and black paper cut into smaller strips. They're easier to work with when they're small. All you do is pour the nail polish on the surface of the water and then dip your paper in and then let it dry. And you can see here they are still wet. And here they are dry. We did this last year with a different brand of clear nail polish, and we got a little bit of a different result. We didn't get the string, like the stringiness on the sides of the paper last year that we did this year. So you can kind of play around with it and see. We've done this so many times. All you need is water, 7 cups, food coloring, and then you want red, skip 1, blue, skip 1, yellow, skip 1, red, and then some paper towel. So I already put the food coloring in, so all you do is fill up the cups with food coloring and leave the other cups empty, and then fold your paper towel and stick them in like this. And then you wait and you will see the water travels up the paper towel with capillary action, a lot like plants. And then when the colors mix, you get the rainbow. Alright, so what you'll need is a container with a lid. We're using a mason jar, and some water and jelly crystals in blue, red, and yellow. We got ours from Spangler Science, and I will include a link to those below. So all you do is you take about 2 teaspoons. For this size, it's about 1 teaspoon per 8 ounces. And then you fill the cups up with water and let them absorb the water. And then 4 hours later, you have these big, beautiful jelly crystals. And then you want to pack it into your container with, in the order of red, blue, yellow, and then red again on top. And you really want to make sure it's packed in there really tight. And then you wait 24 hours and you will have a rainbow. What you'll need for this is a paper towel tube, an old CD, tape, either scissors or a knife, and some white paper. Then the first thing you're going to do is just cut a slit. I found the scissors to work a little better. Just cut a 45-degree slit into one side so that the CD will kind of slip in there. And then on the other side, you're going to cut a little hole, and that's the part that your child will look through. And then you're going to cut a little circle for on top and tape that down. And you could also paint this. That would be a really fun way to decorate it and make it their own. And now they can see rainbows. What you'll need to create a Skittles rainbow are Skittles, obviously, a plate, and some warm water. All you do is you arrange the Skittles in rainbow order, or really whatever order you want, and then pour some warm water on it and then watch the magic. And this happens because Skittles are made from mostly sugar, and sugar dissolves in warm water pretty quickly. It's a really neat thing to see. So what you'll need is some jars, baby oil, and water, and then food coloring. So what you want to do is put your oil in first with your food coloring, and then you can shake it to mix the oil and food coloring together so you have kind of a colored oil. And then once you're done with that, you can add your water on top of that, and then the oil will float on top of the water, of course, because oil and water don't mix, right? And then I added a little bit of blue to color the water, and when you shake it, when you mix blue and yellow, it makes green. But the oil on top stays yellow. So this is a really fun experiment to talk about color mixing and to talk about density. So all you need for this is milk, dish soap, food coloring, and some Q-tips. What you want to do is pour your milk onto a plate and then put your food coloring on in whatever pattern you like. We've done this so many times. If you've been following this channel for any length of time, you've probably seen this experiment. It's really fun, especially with the preschool younger crowd. And then you stick, or you put a little bit of dish soap on the end of your Q-tip, and then stick it in. And just watch the magic. What you need for this is corn syrup that is dyed purple, blue dish soap, green water that's dyed green, olive oil or any vegetable oil, and rubbing alcohol that is dyed red. And we just use food coloring to dye those things. And then we put the corn syrup on bottom, the dish soap was next, then we added the water, and I poured it in slowly because I didn't want the water and soap to mix. And then I added the olive oil, and again, you can really use any oil. We just had olive oil on hand, and it's yellow, so it worked. And then you add the rubbing alcohol. Little tip with the rubbing alcohol, we kind of ran into some problems. I think I poured it too fast, and it went underneath the oil and kind of mixed with our green layer. If you spoon it on top of the oil, it probably will work better. But that is our density rainbow. And my son wanted to see what happens if he shook it, so we shook it, and then we tipped it over to see what would happen if the corn syrup would sink to the bottom, and we just had a lot of fun with this experiment. You could also put different things in and see how far they sink down, which layer they sink down to. You could use a ping pong ball or a dice, lots of different things. So what you'll need for this is borax, some hot water, pipe cleaner that we made into a rainbow shape, a pen or pencil, and a tablespoon. So you're going to want about 3 tablespoons for this size. You just want it to be a super saturated solution. And then you stick in your rainbow and wait overnight, and crystals will appear. I did forget to record the our rainbow. So here is our ornament that we made last year. All you need for this is water, food coloring, and some white flowers. Last year we did roses, this year we're doing these. And then you just stick your flowers into the colored water and it will soak up the color and go into the petals. Alright, to make this you're going to need some vinegar, ice cube tray, some galvanized nails, copper wire, and an LED light. Then you're going to take your copper wire and wrap it around your nail. And you want to leave kind of a tail, a little bit of copper wire out. And when you put it in the ice cube tray, you want that little tail end of the copper wire to go into the next well of the ice cube tray, so into the next little ice cube piece. So once you have all of that, you just keep doing that, and once they're all filled in, you pour the vinegar into each well of the ice cube tray, and that is what is going to create your circuit. Then all you do is you put your LED light in, and it should turn on. And here you can see the light a little bit better. Pretty cool, right? Alright, what you'll need for this is some magnets, some rare earth magnets is what we're using, copper wire, wire cutters, and a AA battery. And then you just take your magnets and put them at the bottom of the battery, and you take your copper wire and cut it. And the most important thing and the hardest part of all of this is you really want your wire to be balanced on either side. So you want to try to make it the same length on either side, that way it balances out. And then you want it long enough so that the copper touches the magnet. So this is demonstrating something called Lorentz force. This is the force that is generated when electricity moves through a magnetic field. So our copper wire is conducting electricity from one end of the battery to the other. As it moves through the magnet on the negative side of the battery, it creates a force which causes the wire to spin. And you can really play around with it and see. The closer that we got our copper wire to the magnets, the faster it spun. I really encourage you to just play around with it and have fun. Create a lot of these and write down the differences that you notice. What you need for this is a multimeter, some copper wire, some test leads, a lemon, some nails, and wire cutters. I'll tell you this, you need one galvanized nail for each lemon that you use, and the more lemons you use, the stronger your battery will be. So what you're going to do is just cut a piece of copper wire, and you only need one kind of stick for each lemon. We're only using one lemon for this. And then all you do is you put the copper wire and the nail in your lemon. I'm not sure what I did there. And then you hook up a test lead to the copper wire and then to your multimeter, and then you hook it up to the nail and then to your multimeter to create a current. Do not do this without your parents' supervision. Safety is very important. What you're going to need is a 9-volt battery and some steel wool. We're using a piece of cardboard just to protect our table. And then you just simply touch the battery to the steel wool. And when both battery terminals touch the steel wool, the electrons from the battery move through the steel wool to make a complete circuit. And the electrical current heats up the wire, and the heat causes the iron in the steel wool to react with the oxygen around, and that reaction causes the sparks that we can see. Alright, so what you'll need for this is some vinegar. I have a little dish here, aluminum foil, some thin cardboard, some tape. It doesn't have to be electrical tape, it could be even Scotch tape, some test leads that have been cut and stripped on the end, some pennies, and a multimeter. Then you're going to start by just tracing your penny out onto the thin cardboard and cut a bunch of circles. I have a bunch right here, and then you soak those little cardboard circles in vinegar. And you want to do the same thing with tin foil. I folded the tin foil and then just cut a little circle, and there's a bunch. And then you're gonna start your battery. So first I put the test lead wires down, and then I put the penny, and then a piece of cardboard and tin foil, penny, cardboard, tin foil. You just keep layering that. The bigger your stack, the more powerful your battery will be. I think I had 8 or 9 pennies, and you can see I will hook it up and we'll test the voltage. What you need for this is tinfoil, Christmas lights, tape, some batteries, 9 volts, some AA or AAA, paper, and wire cutters. You want to cut the bulbs off and then strip the wires so that you can actually see the wires. And then you want to tape it, tape the tinfoil to paper, and then tape the wires to the tinfoil to create a circuit. And you can create a parallel circuit like we have here, and we're using 2 AAA batteries, but you could use 1 AAA, 1 AA, 2 AA, whatever you have on hand. Or you can create a series circuit like we have here, and we're using the 9-volt battery with this. And then we wanted to see if we could make the lights brighter, so we took one of the lights out of the circuit and then reconnected the circuit to see if we could make the lights brighter. And we did! This is super simple. All you need is some grapes and a knife and a microwave. And then you want to cut the grapes in half, or almost all the way in half, leaving just a little bit of skin between them. So the electromagnetic waves in the microwave cause electric current to move back and forth between the 2 halves of the grape. That current is concentrated on that one little piece of skin between the 2 halves, and that'll heat up and dry out. Then the current has to move up through the air, creating a spark. All you need for this is a piece of PVC pipe and some Christmas tinsel. Take 3 to 6 strands of tinsel and tie them together on each end, about 6 inches apart. And then you cut off the excess on the end. And when you rub the pipe in your hair or give it a static charge, you're giving it a negative static charge. The orb is at first attracted to the pipe because it has a positive charge, but as soon as the orb touches the pipe, it picks up a negative charge. And since the pipe is negative and the tinsel orb is now negative, they repel away from each other, and it makes the orb levitate. What you need for this is insulated copper wire, a D-cell battery, a nail, and then something that you can pick up with your magnet. Paper clips might work better than these nails, but that's what we had. So first you're going to take your nail and wrap your wire around your nail, And then once you have it all wrapped up, you can take off the coating, strip the wire, so you can see the wire, and then you will attach it to either end of your battery. You can see that it's not picking anything up right now, it's not magnetic, and then as soon as you hook it up to the battery, it's magnetic. What you need for this is a cutting board and a knife, a couple potatoes, some galvanized nails, some pennies, a multimeter, and some test leads. And then what you're going to do is you're going to cut your potato in half and then cut slits on one end, and that's where your penny will go. You're going to just stick your penny in those slits and then stick your nail on the other side, and then you're just going to hook it up to your test leads. So you're going to hook one part of your test lead to the nail and then the other part to the penny and go around to create a circuit. And once you have them all hooked up, you will hook up your multimeter so you can see how much voltage you have. So what do you think that we could power with our potatoes? It's hard to see, but we did have enough power to power up this little LED. need for this is a pop can, black marker, safety pin, and some paper. Then you draw the shape of the opening on the pop can and cut it out. It should look like this. And then slip it underneath your full pop can so that it looks like it was already opened. And then carefully pierce a hole in the side of your pop can and empty it to about 1/3 of the way empty. Then you can crush the can to show your audience that it's empty, or you could lay it on its side and come across it to do your magic trick, maybe at a family gathering or event. So what you want to do is put your thumb on the hole that you created, and that's going to hold in the pressure, and then you shake the can, and as you shake the can, the pressure builds from the carbonation and makes the crushed can uncrushed. And then you slip the paper away and open it up, and everybody will be amazed. What you'll need for this are 3 cups that you cannot see through, scissors, a diaper, and some water. Then you take your diaper and cut it in half to rip it open and get all the super absorbent polymers inside the diaper, and then put those into your cup and they will soak up the water. And ta-da! No water comes out. Your friends will be amazed. Smart ink. Wake up and draw a circle and go to sleep. And wake up and make the circle a square. Yeah, fill it in. That's a nice square. Okay, go to sleep. Wake up. Dance around. What you'll need for this is ferrofluid. I'll include a link to where to get that below. Magnets and a sheet of laminated paper. We used an old activity sheet that we had in the schoolroom. All you do is pour a little bit of your ferrofluid on the paper and then move the magnet underneath. And because ferrofluid is magnetic, it makes the ink look like it's coming alive. What you'll need for this is some water, lemonade Kool-Aid packet, sugar, and a couple cups. Magic wand optional. And then inside of your sugar cup, just include the Kool-Aid packet as well.
Watch this, Dad. Ta-da! Fire money. Ta-da!
Do not do this unless you have adult supervision. But what you're going to need is a bowl, salt, a candle, and 70 or 50% rubbing alcohol. And then you're going to pour the rubbing alcohol into the bowl and add salt. Now what the salt will do is make the money burn orange. If you don't add salt, the flame will burn blue. And a quick side note, I am using my hands. To make this more safe, you could use tongs. You soak your money completely. You make sure it's completely soaked. And again, use tongs, not your fingers. The water is the first to be heated at its boiling point, then vaporized by the heat of the combustion from the burning alcohol.
Try that again. Abracadabra and kazoom. There we go. Cook it. That's not
What you'll need is a couple pencils and a plastic bag, and of course some water. How does this work? Well, the plastic bag is made of polymers, and polymers are a long chain of molecules, but when you poke through the plastic, you're stepping between the long strands of molecules, which creates an airtight seal around the pencil, keeping all the water inside.
abracadabra and kazoom.
Okay, good job. Ready? Think it'll pop?
Yes.
It didn't.
Let's try that again.
Do not try this without adult supervision. What you'll need is a balloon, a match, and a candle, and then a little bit of water. So the secret is you put a little bit of water in the balloon before you blow it up. This happens because the water is conducting heat away from the surface of the balloon. As the water closest to the flame heats up, it begins to rise, and the cooler water replaces it at the bottom of the balloon. What you'll need is a straw and a potato, a couple straws if you want your friends to try it. You might want to start by asking your friends if they can pierce a drinking straw through a potato. They will find that they cannot do it unless they know the secret. The secret is you put your thumb over the end of the drinking straw. And what that does is it traps air inside of the drinking straw. And when you trap air inside the straw, the air molecules compress and give the straw strength, so you can pierce it right through that potato. All you need for this is a piece of PVC pipe and some Christmas tinsel. Take 3 to 6 strands of tinsel and tie them together on each end, about 6 inches apart. And then you cut off the excess on the end. And when you rub the pipe in your hair or give it a static charge, you're giving it a negative static charge. The orb is at first attracted to the pipe because it has a positive charge, but as soon as the orb touches the pipe, it picks up a negative charge. And since the pipe is negative and the tinsel orb is now negative, they repel away from each other, and it makes the orb levitate. Can I do it with my finger?
Yes.
Nothing happens.
Go.
What you'll need for this is a finger, some dish soap, water, pepper, and a plate. After you put some water on your plate, shake some pepper on your water. And then here's where the secret comes in. Put a little bit of dish soap on your finger, and then as soon as you touch it, you're lowering the surface tension of the water by adding the soap. Pretty cool science.
Whoa.